Hi everyone. A particular concern in any experimental study is its internal validity. In today's video, I will explain what is internal validity, but focus more on the potential threats to the internal validity in an experimental study. In this regard, with the use of examples, I will highlight 7 threats to the internal validity in an experimental study. Firstly, what is internal validity? Internal validity is the extent to which the research design and data it yields allows the researcher to draw legitimate conclusions about the cause and effect or other relationships between the variables. In experimental designs, internal validity is very essential. Without it, a researcher cannot draw any kind of conclusion or firm conclusion about the cause and effect. And that is, after all, the whole point of conducting an experiment. Let's take an example. Let's say you have just learned about a new method of teaching science in elementary school. You want to conduct an experiment to investigate the method's effect on the students' science achievement test scores. You find two 5th grade teachers who are willing to participate in the study. One teacher agrees to use the new method and in fact is quite eager to try it, and the other teacher wants to continue using the same approach. Both teachers agree that at the end of the school year, you can give their students a science achievement test. Are the two classes the same in every respect except for the experimental intervention? If the students taught with the new method obtain higher achievement test scores at the end of the year, will you know that the method that you adopted was actually the cause of the high scores? The answer to these questions is no. The teachers are different. One could be a female, the other could be a male, and they both will have different personalities, educational background, teaching styles, and in addition, the two groups of students may be different as well. Perhaps the students instructed by the new method are on average more intelligent, they have higher IQs, maybe they were more motivated than the other group. And there could be some subtle differences, maybe including the interpersonal dynamics in the two classes, the light, the temperature, the noise levels within each classrooms. Any of these factors, and perhaps maybe we haven't even thought of many, can affect the achievement test scores. So when you are comparing two or more groups that are or might be different in ways, in addition to the treatment or the intervention you are carrying out, you have something called confounding variables, which makes it difficult to draw a conclusion about cause and effect relationship. So in today's video, I will focus on the 7 main threats to the internal validity of an experimental study. So the researcher, when they start studying the possible effects of an intervention on a variable, a number of confounding variables come into play, and these threaten the study's internal validity. The first one could be history, which is an uncontrolled outside event occurring between two measurements of the dependent variable, bringing about a change in the dependent variable. For example, a noteworthy event in the local community might change participants' knowledge, abilities, or emotional states in ways that affect the second measurement of the dependent variable. Now let's take an example. Let's say you are trying to find out if respondents feel that vaccinations are important or not. Now before COVID, maybe there were many people who would have said, no, vaccinations are not important. But COVID being that noteworthy event in the community might change some of the people's perceptions or abilities or emotional state, making them feel that vaccinations are important for us to survive. So this is an example of how history can be a threat to the internal validity. The second threat can be maturation, which is a change in participants' characteristics or abilities, which might simply be the result of the passage of time. For example, you are trying to study the hand-eye coordination of children, which may make normal development gains with the passage of time as the child gets older. So you have to make sure that you control for this confounding variable. The third threat could be testing. So taking a test at one time influences participants' knowledge or participants' performance during a subsequent administration of the test, perhaps simply as a result of practice in taking the test. For example, people who may take a multiple choice test at one time may gain the general test taking skills that enhance their performance on a subsequent multiple choice test. So there will be a learning effect where people will now be able to anticipate what to expect in this test. The fourth threat is instrumentation. When a change occurs in how a measurement instrument is used from one time to the next. For example, a researcher might have one research assistant rate participants' performance on the first occasion, but then have a completely different research assistant judge their performance on the subsequent occasion. And any observed change might be the result of the two assistants' differing standards for rating the performance. The fifth threat is statistical regression. People who score extremely high or low on a measure at one time are likely to score in a less extreme manner on the same measure at a later time. That is, extreme scorers tend to drift towards more average performance during a subsequent measure. Let's take an example. A researcher might assign people to, say, one of two groups, high anxiety or low anxiety, based on their extremely high or low scores on a self-reported questionnaire designed to measure general anxiety level. Especially if the initial extreme scores were the result of people's temporary circumstances, that are circumstances which might have made them feel exceptionally anxious, the supposedly high anxiety people would become less anxious and the supposedly low anxiety people would become more anxious regardless of any experimental intervention the two groups might undergo. The sixth threat is selection, which is a bias that exists in how members of different groups in a study are chosen. For example, when recruiting college students for a study, a researcher might put all students enrolled in a 8 a.m. class in one treatment group and all students enrolled in a 2 p.m. class in another treatment group. Now, students who are taking the early morning class might be different in some significant way. For example, they might be more active than those taking the afternoon class, and that will affect the research data as well. Finally, the last threat is the attrition threat, when members of different groups drop out of the study at proportionally different rates. For example, one group in a study might lose 25% of its members before the final measurement, whereas another group might lose only 5% of its members. Hence, even if the two groups were equivalent with regard to the important characteristics at the beginning of the study, after people leave the study, they might be different in some significant way later in the study simply as a result of the differential dropout rate. Now, there could be a eighth threat to the internal validity, which talks about interaction between or interaction among these threats. For example, if students in 8 a.m. class are assigned to one treatment group and students in a 2 p.m. class are assigned to a different treatment group, and if students in the 8 a.m. group drop out of the study in greater numbers than students in the 2 p.m. group, any final difference observed in the dependent variable might be the result of the fact that the early risers are for some reason more likely to drop out than students who like to sleep in a bit. In this situation, it will become virtually impossible to disentangle possible effects of an experimental intervention from effects of selection bias or differing dropout rates or even the interaction between these confounding variables. So guys, make sure if you are designing an experimental study, you control for these confounding variables. There will always be some confounding variables, but if you can justify or if you can show that you controlled for it or you addressed it and you identified it, the examiner and reviewer will understand your study better. Thank you for watching today's video, and I hope to see you soon with my next video. I hope these videos are being beneficial. I try to keep them short for the benefit of my students. Thank you and see you soon. Bye.